the initial value theorem. This theorem says that the value of a variable, a time-dependent variable, initially, or at time equals 0, can be found by taking the limit as s goes to infinity of s times f of s in the frequency domain. So notice this is kind of the inverse of what we saw for the final value theorem. In the time domain, as time goes to 0, or when time is 0, is on the left-hand side, and we are analyzing in the frequency domain, though, what happens as the frequency, or s, goes to infinity, and of, again, s times f of s. So this is going to allow us to do analysis based on the frequency domain and figure out what's happening initially in the time domain without having to actually do an inverse Laplace transform and figure out what is f of t. We can know f of 0, and pairing this with final value theorem, we can know the steady state value of little f without going into the time domain. Now, to use the initial value theorem, we have the same restriction as we had for the final value theorem, that when we look at s times f of s, all of its poles must lie in the left half plane. That is to say that all poles must have negative real parts. Again, as with final value theorem, this is a little bit more restrictive than what the theorem actually is, which would allow a single pole to be at 0, but we're going to go with this definition and these restrictions for this course. All right, so now we can take a limit as s goes to infinity and know what happens to our variable in the time domain initially. So let's go through, again, an informal proof to show that this is the case. So I'm going to start where I did in the final value theorem. I have the Laplace transform of my variable, f dot is what I want to take the Laplace transform of. And once again, I have the strict definition, the real definition of the Laplace transform, which is this integral. And from what we know from the Laplace transform table, we know it's going to be s f of s minus f of 0. So this looks exactly the same as where we started before. But now I'm going to take this integral term, and instead of seeing what happens as s goes to 0, I'm going to see what happens as s goes to infinity. So I'll take that middle term, and I want to take the limit as s goes to infinity. Okay, so what's going to be impacted here? We have that e to the negative st going on. The f of t is not affected because there's no s in it. So what's going to happen is we're going to get an exponential to a negative, and that exponent on e is going to get really, really big, but it's going to be negative. So it's going to be a really big negative number, which means that this term is going to go to 0. So that term goes to 0 because e to a very big negative number is going to get really, really, really small. So in the limit as s goes to infinity, it will go to 0. Well, the integral 0 is just going to give us 0. Now I'm going to take this term on the right, this s f of s minus f0, and I will hit it with the limit as s goes to infinity as well. So I'm maintaining my equality. All right, so the first term, s f of s, well, there's nothing I can really simplify there because, again, I don't know which grows or shrinks faster, the s term or the f of s term. But this f of 0, well, that's not affected by this limit because there's no s in it. So the f of 0 can actually be taken outside of the limit here. All right, so we know from above that this integral term is equal to this s of s term on the right. I took the limit as s went to infinity of both sides. So this term is also going to be equal to this term. So I can put them together. Since the integral term just went to 0, all that really happened was I moved this f of 0 over to the right-hand side, and then I switched the left side and the right side. So this lets me say that f of 0 is the limit as s goes to infinity of s times f of s. And that is exactly the initial value theorem. But again, we first need to show that our variable f, or whatever the dependent variable is stable by showing that s times f of s has poles only in the left half plane. Then the initial value theorem is going to apply, and the final value theorem is going to apply.